Okay, so 3.4, again, we're going to start with example 5 here. And so we've got this solving a population growth problem. And so it starts out with the following table, which I've got right here. The following table shows the approximate population annual growth rate of the United States and Pakistan in 2010. It says use the alternate population model. P of t is equal to P sub 0 times 1 plus r raised to the t, which is what I have written right there. It says where P of t is going to be our population at time t, P sub 0 is the initial population, r is your growth rate, and t is the time in years since 2010. Assume that the growth rate for each country stays the same. Alright, A tells us to estimate the population of each country in 2020. Well, in 2020, that means that t is going to be 10 years because it's 10 years past 2010. Alright, so when we look at the U.S., we already know that the initial population is 308 million. The growth rate was 0.9%, so 0.009. We know t is going to be the 10 years, which is listed above, and we're after the population in it. So we're after the amount at time t, so the amount in 10 years. So we're going to use our equation. So P equals the initial amount times 1 plus the rate raised to the t. And so we can plug that into our calculator, and we should get approximately 336.87 million people. And then we're going to do the same thing for Pakistan. So in Pakistan, we know that the initial population was 185 million people. The growth rate was 2.1%, so 0.021. And t is still going to be 10 years because we're still looking for its population in 2020. So we're going to plug into our equation. So P equals the initial amount times 1 plus the growth rate raised to the time, which we know is 10. We're going to plug this into our calculators, and we should get approximately 227.73 million people. Alright, so moving along here, going on to B. B wants to know in what year will the population of the United States be 350 million people. So now it wants to know when, so we're after T, the population will be 350 million. So that's my population at time t. Alright, so for B. So we already know our initial amount is the 308 million. We know that, we also know the ending amount is going to be 350. Let me do P of t. It's going to be 350 million. We know the rate is still 0.009, and t is what we're after. So when we set this up, we get 350 equals 308 times 1 plus 0.009 raised to the t. Well, I'm after t. T's in the exponent. So this goes back to what we did at the very beginning here, 3.4. We need to get the exponential expression by itself. So let's move this 308 over. And so I'm just going to keep this as 350 divided by 308 equals, I'm going to go ahead and add the 1 plus the 0.009, and it's raised to the t. And then the next step, remember, was to log both sides. So the natural log of 350 over 308 equals the natural log of 1.009 raised to the t. Step 3 said to use the power rule, so we're going to move this t in front of its log. So the natural log still at 350 over 308 equals t times the natural log of 1.009. And then the last step is just solve for the variable. So we're going to get rid of the natural log of 1.009 by dividing it. And so we get t is equal to the natural log of 350 over 308 divided by the natural log of 1.009. So we're going to put this in our calculator, and it's going to be approximately 14.27 years. Well, 14.27 years after 2010 would be during the year 2025. So either one of these. Because remember, the 14 would be the end of 2014, and the 0.27 puts us into 2025. So either one of those would be correct. All right, and finally in C, it wants to know, in what year will the population of Pakistan be the same as the population of the United States? So we want to know, when will the population of Pakistan equal the population of the United States? And so when we did the population in A, we said Pakistan, remember, was the 185 times the 1 plus 0.021. I'm going to go ahead and add that together. Raised to the T. And we want to know when that will equal the U.S., which was the 308 times the 1 plus 0.009. So I'm going to go ahead and add those together. Raised to the T. And so now we're just going to solve. We've got numbers in front of both of the exponential expressions, so let's move one of them to the other side. So it doesn't really matter. I'm going to move this 185 over. So I got 1.021 to the T equals 308 over 185 times 1.009 to the T. And so now let's get the t's on the same side. This is being multiplied, so I'm going to divide by 1.009 to the t. All right, so now on the left side, remember, we had a rule we talked about earlier in one of the lessons. I don't remember, I think it was 3.1, that it said if we had like m over n raised to the x, both of these would get the x. Well, we're going to do it backwards. Since both of these two numbers have a t, we're going to pull it out to the front. So what we have here is the 1.021 over 1.009 raised to the t equals the 308 over 185. Well, now we've got the exponential part by itself, the exponential expression by itself. That was step one on solving exponential expression with exponents when we could not get like bases. So then remember, we're going to log both sides, and so I'm going to bring that over here and try to squeeze this in over here. So we're going to have the natural log of 1.021 over 1.009 raised to the t equals a natural log of 308 over 185. Then we're going to use the power rule, so we're going to take this t and move it in front of its log. So t times the natural log of this equals, and we're not going to change this other side, that's a 0, and then solve for t. So we're going to divide by that natural log of 1.021 over 1.009. So when we do that, we're going to get t equals the natural log of 308 over 185 divided by the natural log 1.021 divided by 1.009. Again, be careful putting this in your calculator, but we should get approximately 43.12 years, which if you put that after 2010, this is going to be during 2054. And that's example 5.